Welcome to the Radically Genuine Podcast. I'm Dr. Roger McFillin. Right now, as you're listening, it's estimated that somewhere between 40 to 60 million Americans are taking an SSRI. Pregnant women, children, teenagers, your neighbors, your family members, all taking pills their doctors assured them would correct an underlying genetic or biological abnormality. Even if the prescriber does not fully adhere to the chemical imbalance theory of mood and anxiety, they will at least communicate that the potential harm of taking these drugs is rare and the side effects are relatively benign. Just something to assist you in getting through a difficult time. Or worse, prescribing for a range of conditions that mask symptoms they've identified as major depressive disorder, pain, premenstrual symptoms, menopause, premature ejaculation, and inexplicably anorexia. They tell you these drugs increase serotonin. They tell you they're safe. They tell you the benefits outweigh the risks. They tell you withdrawal is rare and can be mitigated with standard linear taper protocols. The adverse effects, the health effects, long-term, short-term, rare. They convince you that this disease, the one creating the suffering, is not a reasonable response to events in your life, but a treatable medical condition. And if not treated with these drugs, more damage will be done. Every single word is a lie. Your doctor doesn't know they're lying. They're repeating what they learned in medical school from textbooks written by pharmaceutically funded academics. They're following guidelines created by major medical organizations on the pharma payroll. They genuinely believe they are helping you. Today, we're going to prove that SSRIs are cellular toxins that destroy the very foundations of human energy production. We're going to demonstrate how they systematically dismantle your mitochondria. The powerhouses that don't just give you energy, but generate the light that connects your consciousness to everything around you. And this isn't hyperbole. This isn't a conspiracy theory. This is documented biochemistry that the psychiatric establishment fails to even remotely understand. In fact, today's very discussion will be completely foreign to those pushing these drugs. My guest today has done something I believe is remarkable. While most of the country remains entangled in antiquated debates regarding SSRI effectiveness, he chose to ask a different question. What are these drugs actually doing at the cellular level? His answer should change everything you believe you know about these drugs and how they're presented to patients. I'm honored today to introduce Dr. Chris Masterjohn. He's the host of the Mastering Nutrition podcast and founder of Mitome, where he helps people optimize their mitochondrial health through advanced analysis. He received a PhD in nutritional sciences from the University of Connecticut, completed his postdoctoral research at the University of Illinois. He's worked in academia. But right now, he's choosing to work independently, and this is often where we get the most accurate information, when people are free from institutional constraints. He's in science, he's in research, he's education. He's got an excellent podcast, excellent podcast and Substack. His groundbreaking SSRI series on Substack is absolutely revealing. And he's really proving that we have the fundamental concept of SSRIs wrong. They're not just antidepressants. They're potential poisons. They numb emotions. They have effects that are used psychiatrically, but we have to get into the weeds on this. We have to understand the science of this. We need to understand the implications of his work. And really, when it comes down to it, this is about informed consent. This is an important conversation for all prescribing medical professionals, all mental health professionals, and anyone on an SSRI or considering taking an SSRI. Dr. Masterjohn, thank you for joining the Radically Genuine podcast.
Thank you for having me. It's a pleasure to be here.
Okay, so you've dedicated a lot of your career to studying mitochondrial health. What made you start looking at psychiatric drugs, specifically SSRIs?
Well, for the last about year and a half, I've been giving about 150 people a high ticket VIP biochemical analysis where each person's getting about 40 to 60 hours of work analyzing their history, their whole genome sequencing, raw data, their amino acids, organic acids, acylcarnitines, acylglycines, vitamins, minerals, intracellular and extracellular metabolic panels, respiratory chain testing, which is what the Mitome product is focused on, and cross-referencing that, and then essentially getting as a product what is best described as a textbook about their personal biochemistry and how it's determined their entire life history, and a nutritional protocol that's personalized to them. And so over the course of doing that, there were cases that came up that motivated me to better understand what they were going through. And in 150 of those people, 2 of them, who were both males, had as their primary problem SSRI withdrawal-induced profound mitochondrial dysfunction. Both of them were quite different in their presentations as well as the underlying biochemistry, including even in some of the respiratory chain data where the new test that I offered, Mitome, if I had run that alone on them, it would have indicated quite different types of mitochondrial dysfunction between them. The second one just got his protocol a week or 2 ago, so I can't really say much about how much it's impacted him. But the first one had gotten his protocol 8.5 or probably 9 months ago by now. And he had given me updates at the 6-week mark, the 6-month mark, the 8.5 month mark. And he's just, feels like a completely different person. But in his case, he primarily had post-SSRI sexual dysfunction, or PSSD, which is an interesting syndrome because, number one, SSRI-associated sexual dysfunction was discovered first, but then it was discovered that you could go off the SSRI and still have it, which became post-SSRI sexual dysfunction. But then it also turned out that a subset of PSSD, it doesn't even onset until after the person is withdrawing from the SSRI, which actually should make it a subset of SSRI withdrawal, because it's induced by the withdrawal rather than induced by the SSRI and then stays there. And then the other case was someone who developed sexual dysfunction on Zoloft, which he had been on since he was a child, and he was a college student when the sexual dysfunction started precipitating. So he tried to get off the Zoloft repeatedly, but it was a very difficult road. But the end of it was the side effects that he was getting from the Zoloft made him ultimately decide that he was better off without it. But without it, he had new onset chronic fatigue. And it was so bad that he spent a whole month not being able to get out of bed. And this is in his early 20s. Spent a whole month not being able to get out of bed. He had a portable bedside toilet, and someone had to give him a sponge bath while he was in bed to clean him. And that was within a whole 1 year span where he was unable to stand up by himself in the shower. So we're talking really extreme mitochondrial dysfunction that appears to be driven by withdrawal from the drug. And, so there's only 2 cases, but, you get but there of course is a whole body of literature on SSRI induced side effects as well as SSRI withdrawal induced side effects. And it kind of feels like a mafia style drug because you get put on it and then it causes you distress that if you go off, it causes you more distress. And so a lot of these people are locked in between a rock and a hard place. But the fundamental problem with getting anywhere, apart from recognition, so you did mention in the intro that the mainstream story is withdrawal doesn't happen that often, it doesn't last that long, and it usually isn't very severe. those we really have no idea what the actual incidence is, because they base this off trial data, and all the trials are short. And if you synthesize the trial data with the very few observational studies that have been done, you get the impression that the length of time that the person is on the SSRI is a direct determinant of the incidence and severity, to the point where if someone's on an SSRI for a few years, there's like a 95% incidence of withdrawal and maybe a 30% incidence of severity. But if you look at the studies where they just took people who had SSRI withdrawal symptoms for years, the average person had been on the SSRI for 8 years in those studies. So if you synthesize them all together, it looks like you have to be on the SSRI for at least a week and maybe 6 to 8 weeks to even get any withdrawal symptom. But between 8 weeks and 8 years, there's like a direct linear and possibly exponential rise in both the incidence and severity of the withdrawal problem. And so you get these people that think that they say, well, the randomized controlled trials are where you want to look. But that it is true that a randomized controlled trial is the best form of evidence for causality. But as the founders of evidence-based medicine have pointed out in peer-reviewed papers that they wrote years ago, evidence-based medicine has been hijacked. And the way it's been hijacked is that pharma took over the RCTs and controls them, and so determines what questions they ask and how they're asked, which determines what types of answers you get. So if you want to make a randomized controlled trial and you want to then test people who go off the drug after the trial and follow them, all you have to do is make it relatively short compared to what the observational studies say is the length of time you have to be on it to wind up having your entire career, family, and finances and life wrecked for the next decade. So in any case, that's the gist of the intro.
Yeah, well said. I'm certainly the story that you just discussed about the gentleman in withdrawal is something that I'm well aware of. I receive emails and consults regarding this. I've seen it in clinical practice. And regarding the role of these clinical trials and the pharmaceutical industry taking over the clinical trials of their own products, there's so many games that can be played, which include placebo watching periods where they'll withdraw somebody in the placebo group from a drug, induce withdrawal, and then use that as a way to create efficacy in their product. But I want to start a little basic here. Most people have heard of mitochondria because we're taught this in like 9th grade biology, right? It's the powerhouse of the cell. But can you explain what mitochondria actually do in our bodies and why they're so much more important than just making energy?
Well, you can look at mitochondria as doing more than producing energy, but I do think it's better to look at I would actually go the total opposite direction that you just did, which is rather than introduce mitochondria as more important than just energy metabolism, I would say we should collapse psychiatry into being mostly about energy metabolism. Because if you go back to the fundamental laws of physics, the second law of thermodynamics says, to put it simply, that if you don't invest energy in something, it turns into total chaos. And you can say that more scientifically, but that's the gist of it. And it's sort of like if you don't invest energy in cleaning your room, it doesn't stay the way it was the last time it was cleaned. It gets messier and messier and messier. And everything that you want in your body to be healthy is to polarize between different states in an orderly fashion that is non-chaotic. So, for example, if you are very, very deeply asleep for 8 hours, and then you're very, very, very awake when you're trying to be productive or when you're trying to perform physical feats, that's a ideal high energy state. And if you are wired and tired because you couldn't fall asleep because your mind was racing when you did sleep, it wasn't that great. You only slept for 5.5 hours, and then you get up and you're tired all day. That's a chaotic, low energy state because you haven't separated those things. And I think if you look at psychiatry, what you're going to see is, mental health is all about being able to compartmentalize where you're spending your energy and how, and is it favorable to a healthy mental state or not? And most psychiatric problems are problems of energy deficits in the brain. And so I do think that it's best to, if someone wants the kind of high level, what does a mitochondria do? I would say that mitochondria are the power plants of the cell. Now, to tie this into other things, I would also say that the creatine system is the mitochondria's energy grid. So in order to spread that energy throughout the cell, creatine is responsible for that. And then glycolysis is the one other way that you can make ATP. That's burning carbohydrate for energy without the help of oxygen in the mitochondria. And that's like a local power generator. Now, if you look, for example, why is that relevant to psychiatry? Well, there's now studies showing that there's multiple studies showing that 5 grams a day improves depression of creatine. There's several studies indicating that 20 grams a day can, for example, make traumatic brain injuries heal in half the time. And there's even some interesting studies showing that sleep deprivation is powerfully mitigated by 20 grams of creatine. So there was one study that came out last year where they had people sip on a placebo or a 20 grams of creatine drink across the night. They made them stay awake and they made them do brain puzzles. And when they were getting the creatine, they were not complaining about being tired and they were doing great at the brain puzzles. But when they were getting the placebo, they were doing a bad job in the brain puzzles and they kept complaining about needing sleep. So I think what these things demonstrate is your brain is just another part of your body, and there is no such thing as a psychiatric drug. Because there are no. I mean, first of all, pharma. Everything that pharma produces is intrinsically inferior to the optimal natural solution that you could produce, and that does not mean that everything that pharma produces is inferior to everything that's natural, nor does it mean that right now we have a natural solution that is better than whatever pharma is doing. But it does mean that if you were to invest the type of funding and societal energy into understanding how you could fix things naturally, you would wind up with superior solutions to pharma for simple reasons that pharma can't make a drug that goes into a specific place in the body and it impacts like one neuron instead of another. And you see this it's so hilarious if you look at the history of SSRI development, because that's exactly what they spent like 10 or 20 years trying to do, because they had this problem that if you, when you start an SSRI, it doesn't do anything for a couple of weeks. And the explanation is that it's inhibiting its own production in the first neuron that would release serotonin, even though it's increasing how long serotonin stays in the synapse. So what they wanted to do was develop a drug that could antagonize the negative feedback loop, but still allow you to get the serotonin up. And they couldn't do it because pharma can't do something like that. And so when you see natural training systems that are that enable you to exercise the pathways that you want serotonin to help with, then you get a massively superior result, because pharma is acting on, does this drug affect some receptor? And it can't put it into one place in your body and not another. I mean, this is also why there's early nausea on SSRIs, for example, because serotonin has a role in the gut in producing nausea, and they haven't been able to make an SSRI that goes into your brain and doesn't go into your gut, especially since they're feeding it to you with a pill. So, if when you find, yeah, go ahead.
Well, I think this is a good opportunity for you to maybe just talk about the sophisticated nature of the serotonergic system and all functions that it affects. Because the narrative that's sold, the very simple reductionist narrative that is sold to the public and physicians and mental health professionals, is that if we increase the availability of serotonin in the nerve cell, that's going to have a positive impact on mood, and that's it.
Yeah. Okay. I'll just kind of back up from the beginning and situate serotonin in its proper context. So serotonin is primarily a whole body chemical acting on cells that are primarily not neurons to regulate energy metabolism, especially in response to hypoxic stress. And I want to say right off the bat, I know when people hear this, it sounds like you're getting strangled or you're drowning when I say hypoxic stress or hypoxia. But hypoxia, you want to think about it in terms of the relative supply and demand for oxygen. So whenever you have a greater demand to use oxygen to produce more energy than what you're breathing in, you have some degree of hypoxic stress, and you're going to respond to it partly and largely with serotonin in a way that will restore the equilibrium. And this can be relevant when you start exercising, and that's why you breathe more heavily when you're exercising, because you're doing things with your body that demand more energy, but now you need to breathe more to deliver more oxygen. This also happens when you wake up in the morning, because your metabolic rate goes down at night, and when you wake up in the morning, it's going to spike up. And there are signals such as light that facilitate that. And interestingly enough, if you look at what happens if you directly interfere with the circadian rhythm in an animal, for example, you can take the pineal gland out, which makes melatonin from serotonin, incidentally. What the main biochemical thing that you see is their hypoxia response goes completely crazy. And it's because the circadian rhythm is designed to say, I know I'm not going to use as much oxygen at night. I'm going to have a lower metabolic rate, but I'm going to divert the little energy that I do produce into, number one, restoring baseline energy supplies, and number two, fixing things and repairing things and detoxing things to help restore general function during the day. And then I know once I wake up and once I'm exposed to light, I'm going to start ramping up the oxygen utilization. And those systems are so complex that you need to prepare them in a cyclical manner. And if you don't, you wind up getting, a massive dysregulation of the oxygen utilization system. So if you look at serotonin in the brain, one thing that you'll see is that it primarily increases if you take in animal studies where they look the animal through the day and they play with the light dark cycle. The main determinant of whole brain serotonin throughout the day is the exposure to light. And if you take an animal through a total darkness, its serotonin, it's not going to be zero, but it's going to be flatlining without the increase in the daytime. And so that in itself is reflective of this. We need to burn more energy during the day and less at night. If you look in the lungs, every time you breathe, some segments of your lungs are more oxygenated than others. Serotonin is going to mediate the distribution of blood flow to the more oxygenated parts of the lungs and away from the less oxygenated parts of the lungs, so that you get full efficiency of oxygen delivery. If you look at, when would serotonin be distributed throughout the body, you're going to see that it's primarily in hypoxia, because the serotonin that's made in the gut gets stored in the platelets that circulate in plasma, and under hypoxic stress, they release the serotonin. That allows the serotonin to go throughout the body and respond to that hypoxic event. And if you look at the things it's doing, it's, go back to why serotonin was named serotonin and look at why SSRIs are named SSRIs, and you'll see a major conflict. So first, it was called enteramine because it's primarily found in the gut. Like whole body serotonin is primarily found in the gut. And that does not mean that your gut is your second brain and that your gut is determining your mood. It means that serotonin is in the gut to regulate the gut. That's why it's there. Then the people that came after that, or there was like two groups that were discovering serotonin at the same time. A couple of years later, they renamed it serotonin to mean what? Sero means it's found in the serum. Okay, so not the brain, the serum. And tonin meant that it regulated the tone of the vascular system by doing what? By constricting vascular smooth muscle cells to constrict blood vessels. How does it do that? Not by acting on the neurological control of the smooth muscle cells. It does that by acting on serotonin receptors that are located on the muscle cell, and they contract in response to the serotonin, right? So now, what does an SSRI mean? The R means reuptake, and that reuptake it's specifically about the synapse in the brain. And so the SSRI name is pretending that the fundamental thing that is happening is it's prolonging the serotonin in the synapse of the brain. But that's not what an SSRI is. It's an inhibitor of the serotonin transporter, which is found all over the body, because when serotonin acts to regulate energy metabolism, yes, it does act on receptors on the outside of the cell, but then it uses the serotonin transporter to get into the cell and then to act on serotonin transporters that are inside the cell, including in the mitochondria, where it helps to do two things. One is regulate mitochondrial function in response to hypoxic stress. And the other thing is there's another serotonin transporter on the mitochondria that serotonin goes into so that it can be converted in the mitochondria to melatonin, which is one of the most important protectors of energy metabolism in the mitochondria. So when you're using an SSRI, if you look at the history, how did you go from serotonin, something that's in the serum and constricts smooth muscle cells to constrict the blood vessels? How did you go from that to SSRI? Funnily enough, it's primarily because of the LSD craze. So there was around the 40s and 50s, no one had used the word neurotransmitter, but they were starting to understand that there were chemicals that impacted the brain. But the popular obsession with LSD, number one, it gave the idea that you can take one thing in your mouth and then suddenly your brain function is completely different. So it was exciting to be able to think that, we can just switch people's moods and their perception. We could just open the doors of perception or close them with a little pill. Had captured the popular imagination, but also the first researcher to show that serotonin had any impact in brain function. He was a blind diabetic, and people. There's no evidence that he ever took LSD. But when people summarize his research, they say that he was blind, but his mind's eye was had such acuity that he was able to see with no eyes the structure of LSD in serotonin. That's sort of like the one sentence summary of what motivated his research, and that was the initiation of the idea that serotonin had an impact in the brain. And then after he published his research several years later, in 1961, I think it was, in the Lancet, was the first ever use of the word neurotransmitter. And so now, 25 years later, in 1986, you've got SSRIs. They whitewashed the history in the way that it reminds me of. So I have a bachelor's in history. It reminds me of the way that when the Soviets took over Russia, and at first it was Stalin, Lenin, and Trotsky, and then when Lenin died, Stalin did two things. One was he embalmed his body and he put it on display. In the Russian tradition, if someone is a saint, their body will be incorrupt. So he made Lenin's body incorrupt and advertised it as Lenin was, the Soviets were the inheritors of the Christian church in Russia. And then he took all the photos of the three of them and he erased Trotsky from it. So Stalin was the inheritor to Lenin. So this is very similar in my view to what they did to serotonin in the rest of the body outside the brain. Had they not had this LSD to massively profitable psychiatric drug pipeline across late 1950s to 1986, we would have had this science about serotonin that was based on what it's doing in the gut and what it's doing in vascular cells and what else does it do. And you do see that science grew alongside the psychiatric science, but most people that are studying the psychiatric roles of SSRIs don't even know about it. And that's what's fascinating is, there's this whole, the lung researchers are studying the role of serotonin in normal lung function and in pulmonary hypertension due to vascular remodeling and stuff like that. And it's all fundamentally connected to how serotonin is primarily a whole body chemical acting primarily to regulate energy metabolism, primarily in response to hypoxia. And it's just totally absent from the SSRI psychiatric understanding.
Great. Thank you for that. Now then, tell us what happens when we prescribe an SSRI. How is it going to affect mitochondrial function? Walk us through what you've found.
Well, it depends. First of all, it depends what SSRI it is, because, and this one of the craziest discoveries that I had was that there are hardly any studies on what SSRIs do to serotonin in the brain. And some of them are, really short-term animal studies. And there's this assumption that the serotonin is increasing because you're on the SSRI. But here's one thing that we know. All of the SSRIs massively deplete circulating serotonin. And there's a randomized controlled trial that looked at the urination of serotonin that basically shows that what's happening is by preventing serotonin from getting into cells, you're increasing its likelihood to spill over into the urine. So you're probably not decreasing serotonin in the gut or the brain necessarily, because those are organs where there's a constant production of serotonin. But on a whole body level, you're massively decreasing exposure to serotonin by causing it to be spilled over into the urine. And then in the gut and the brain, whether you have an increase or decrease in serotonin is probably entirely dependent on which SSRI you're on. And there are a sporadic number of animal studies that look at different SSRIs, and most of them don't go head to head. But if you line them up with what's known about the mechanisms that would determine that, it's basically fluvoxamine and sertraline are very good. So I should say again, all SSRIs go into the cell. And this is never talked about in most of the literature. Most of the literature, everyone assumes they're acting outside the cell to inhibit the serotonin transporter. Sure, but then they go into the cell. And all of the SSRIs equilibrate into the cell so that the SSRI inside the cell, the free concentration of the SSRI inside the cell will be the same as the free concentration outside the cell. Some of them go in and massively accumulate in cell membranes and stuff like that. But they're all going inside the cell. Now, some of them are very powerful activators of the sigma-1 receptor. And the sigma-1 receptor is supposed to be activated in response to stress in a cyclical manner. But the SSRIs that activate it will chronically activate it all the time. And the SSRIs that don't won't. But if you look at the SSRIs that increase brain serotonin, it's the ones that activate the sigma-1 receptor. And if you look at the ones that don't, it lines up perfectly. So basically, to summarize that, sertraline and fluvoxamine are powerful activators of the sigma-1 receptor. Paroxetine is a total trivial, it basically has zero activation of the sigma-1 receptor close to it. And then the others are kind of in the middle. So you can go up from paroxetine to citalopram, and escitalopram have like, a little bit of activation of sigma-1, and fluoxetine is kind of in the middle. And so what you see is if you're on paroxetine, you're probably going to have a decrease in brain serotonin. And if you're on fluvoxamine, you're going to have an increase in brain serotonin. And what's crazy is even the people studying SSRI withdrawal, like the 2025 systematic reviews of SSRI withdrawal, they don't have a single mention of the sigma-1 receptor. And one of the best reviews is in a whole book on, it's the name of the book is Emerging, it's something like Emerging Neurobiology of Psychiatric Drugs or something like that. I forget the exact title, but it claims to be the newest science, right? The whole book doesn't even mention the sigma-1 receptor, which is so crazy. But anyway, you have these people doing studies, and they'll do something with paroxetine and assume fluvoxamine does the same thing, or they'll do something with fluvoxamine and assume that paroxetine does the same thing, but they don't. You have wildly opposite effects on brain serotonin. And that it makes it impossible for them to get at a clear understanding of what the drugs are doing, because they're all different and they're all assumed to be the same. But let me say this. So there are positive effects of SSRIs on mitochondrial function and negative effects. But the positive effects, again, you could have a natural way to elicit those effects that is consonant with the body's physiology and superior to the SSRI, and then you would not have this withdrawal catastrophe. But there are positive effects on SSRIs regulating mitochondrial biogenesis. There are negative effects of them preventing serotonin to get into the cell where it positively regulates mitochondrial function, or to get into the mitochondria where it produces melatonin. And then, if you have a net positive effect of the SSRI on mitochondrial function, then you lose it when you go off the drug. And so you have this situation where there are some people getting side effects on the SSRI due to, and then also the SSRIs can make their way into the mitochondria and poison specific complexes there. So it's very complex. But each individual is going to have genetic variations, nutritional variations, lifestyle variations, epigenetic variations that will determine, if you have good things and bad things, what's the net result of those. So some people are going to get positive mitochondrial function effects on the SSRIs, which I think is why you get positive psychiatric effects of them. It's not because the SSRI is a mood boosting chemical. It's because it addressed that idiosyncrasy, but that comes at the risk of profoundly worse mitochondrial function if someone tries to get off of it. Go ahead.
Okay. Yeah. Let me address that, because the general response when people are identifying that they have a response to the drug, it's often in context of like emotional blunting or some neurocognitive effect that kind of slows down that ruminative thinking. Can you explain what is happening there?
Well, I can try to. So my impression of what serotonin, I think of serotonin as primarily a dissociation chemical. And even if you look outside the brain, a lot of the things that serotonin is doing is, like in hypoxia, for example, it's allowing the mitochondria to dissociate from the normal response to hypoxia by creating alternative means of making energy in the mitochondria in the lack of oxygen. If you look at the gut, like if you eat something that you shouldn't have and you have stress in your gut, vomiting and diarrhea are the two primary effects of increases in serotonin that help separate your gut from the stuff that doesn't belong. And if you look at psychological studies, I think that I think you have a couple things going on. So one thing that we know is that tryptophan depletion winds up depleting serotonin, because tryptophan is an amino acid that comes from the protein in your food that is a precursor to serotonin. Tryptophan depletion, it decreases the aversive response to punishment, is how they call it. So they'll do studies where they, do something irritating to you in response to something trivial that you do, and then they look at whether you change your behavior. And serotonin is required for the to dissociate yourself from the punishment by changing your behavior. So it's like there's a stress here, you don't want to be part of it. Serotonin's going to move you away from it. Now, too little of that is a problem, but too much aversion to negative things is called cowardice and pathological conflict avoidance. So I do think that one spectrum that serotonin is modulating in the brain is just how easily do you separate yourself from the things you don't like by not confronting them. And you do want a happy medium for that. And then there's another spectrum that's happening in the brain, which is separation from the stress of reality itself. And so I think if you don't have enough dissociation from your stress, you identify with it. And when you identify with your stress, that becomes extremely defeatist and overwhelming. So, like I did something wrong, like, oh, I suck, is a bad way to think about that. But that's, if you can't separate yourself from the thing that you did wrong, all you can do is beat yourself up. There's a healthy, happy medium, which is to recognize that you did something wrong, take accountability for it, but recognize yourself as someone who can do better. But too much dissociation from that, I think is, it's just another side of psychological dysfunction, which is you separate yourself from reality in a psychotic break. Or if you're a school shooter, you separate yourself from reality by destroying it. And so I do think that thinking of serotonin as a whole body dissociation chemical can help you think about what it's doing in the brain. But I think it's fundamentally about, you want a happy medium of serotonin function in certain neural networks to allow you to place distance between yourself and the things that you don't like about your life. And if you have too much of that or too little of that, that you have different but potentially catastrophic problems. And so the SSRI is it's not obvious what the SSRI is doing. It's probably doing different things with different SSRIs, but you might get a boost in synaptic serotonin function in certain pathways where you do get those outcomes and move you from a negative position to a happy medium, just at the consequence of making your mitochondria dependent on a drug that's going to wind up causing other problems as well.
The range of effects that we see from these drugs is so vast, and the individual response to these drugs just range significantly. So on one end of the spectrum, there are very known reactions to these drugs that can include akathisia, mania, psychosis. What I'm hearing on a large spectrum is from family members who say, my child or my spouse or my brother or my sister was placed on an SSRI and we saw a personality change. Like this person became completely different than who they were prior. And there's this something called a spellbinding effect, which was first written about by Dr. Peter Breggin, where they don't even realize it's the drug itself that's doing it. Some people rewrite history. So coming from good families or good relationships, and it's almost like they rewrite their own history to an extent. I've seen people become completely disconnected from themselves. The increased suicidal ideation becomes this ruminative process. It's like different than the typical person who is questioning whether they want to live or die. It's like their mind is fixated on like jumping off a bridge or hanging themselves, where it clearly is an SSRI or a drug reaction that I've been able to really see the difference between someone on the drug and not on the drug. And then on the other end of the spectrum, you do see people say, oh, I could just think more clear. And, I don't feel as bad as I just did. So there is this range, and I want to acknowledge the range. My personal belief is the dark side of this is so potentially dangerous, and people do not get the full informed consent regarding the potential harms. And nobody's talking about this in popular culture for the most part, and doctors aren't aware of it, that the drug itself, I believe, is a real net negative in our understanding and evolution of how to overcome the challenges of living. So what do you think about what I just said?
Well, at the high level, my high level response would be, this goes back to what I was saying before, that you cannot design a drug the way pharma designs drugs that carries out an optimal physiological response. And the reason for that is, and this is intrinsic and there's no way around it. And the reason for this, and this applies to any type of drug, the reason it's just sort of like, antibiotics can be very useful, but are they superior to your immune system? Not when it's optimally functioning. And the reason that this is true is because pharma can make something bind to a receptor to carry out some response. That is a molecular and biochemical level response. Now, molecular biology and biochemistry, in a sense, it is where everything happens. Like, nutrients that you consume are acting as biochemical constituents. But the body then layers onto this more complexity with physiology, which is, how do all the different organs interact with one another? And you wind up having something where it's not that you want that receptor to be activated. It's that you want that receptor to be activated in a certain cell type in a certain region of a certain organ, and you don't want it activated somewhere else. So if you look at what is serotonin designed to respond to, and I'm telling you that it's designed to respond to hypoxic stress, there's a fascinating study that was done in mice where they compared antidepressants and ketamine to hypobaric hypoxia training, which is usually used for military pilots to make sure that they can handle like long periods of high altitude. And by the way, I should preface this by saying there's quite a body of literature now showing that the rate of depression and suicide is directly related to altitude, such that chronic altitude exposure. So, for example, in the United States, in the altitude of the capital city in a state accounts for somewhere around 40% of its suicide rate. And so when you think about that, just think of depression is a form of hypoxia intolerance. Okay, now they put the mice through 4 hours a day for 2 weeks of hypobaric hypoxia training. And then they looked at how, first of all, what did that do to their depression-like and anxiety-like behavior? And the answer is it was a powerful antidepressant. But when you looked at ketamine or you looked at antidepressants, the hypobaric hypoxia training lasted 25 times longer than the antidepressant did. And so you get this much more powerfully robust promotion of psychological resilience. Why is that? Because you're not taking now there are chemicals that activate the hypoxia response without having a deprivation of oxygen. So for example, cobalt chloride, you can inject that into a certain region in the brain. It's going to promote, the brain is going to act as if it was hypoxic, right? But you can't take a chemical like that and feed it to someone and get the same result that has the same robusticity to it, because when the body responds to hypoxia, it in its internal wisdom is turning something's up over here, turning something's down over there. It's specifying its physiological response because the body does know how to get one thing into one region of the brain and over into one type of cell type in the dendrite, but not the axon, or the axon terminal, but not the cell body. The body itself does know how to do that. And pharma can't do things like that. The best that they can do to try to do something sort of like that is play with the route of administration, so they can inject something instead of feeding it orally, or they can coat it with something that's supposed to carry it somewhere, but they can't, they think they can do a lot, or they claim, they fool people into thinking they can do that when they can't. So if you look, for example, at the COVID vaccines, the lipid nanoparticles were supposed to, make it stay in the shoulder and get taken up into certain cells. But what it wound up doing is interacting with lipoprotein metabolism to wind up in the lungs and the heart and all kinds of other things. So that, that study with hypobaric hypoxia training is just showing you that what we want to be thinking about is how do we use natural, types of exercise to stimulate the body to respond the way that we want to, rather than throwing in a chemical and trying to force it to.
Okay, I'm going to bring the non-physical into this a little bit. All right. Okay. You're great at identifying and discussing everything from the physical modality. All right. But I'm a psychologist, and I separate. Yeah. Okay. I do separate the mind from the brain. I do see things metaphysically. I was really intrigued by what you were talking about with physics and energy. I see us as energetic beings inhabiting a physical body. I do believe in this evolution of post-material science. I believe it's certainly possible that our DNA and our cells are designed to create or connect to a greater source consciousness. So I want to say that up front. But I want to hear your perspective of what an emotion is. I see it as energy in motion that is designed to serve us. Evolutionarily, it's designed to serve us in so many capacities. So in response to stressful events in our life, we are supposed to move that energy to solve problems, to face problems, and ultimately to come to some kind of conclusion in our mind and our perception of reality, and allow us to continue to grow and evolve. Where I see people struggling psychologically and emotionally, and compare it to people who are, very strong copers, is there's not a fear of emotions. Emotions are there to serve them. They're signals, and they allow them to be able to face and solve problems and move forward and live fully in their moment. People who are in fear of their emotions or struggle with their emotions, they suppress them. Like, there's this evolving psych neuro immunology research that suggests that potentially a very strong root cause of the body being in disease. So I want to get a sense of your understanding of emotions, because a lot of these drugs are designed to alter your emotional states, impact cognitive functioning. They are blunting at emotions is probably the safest and way to be able to describe what happens. People don't feel the same way anymore, and a lot of them feel somewhat handicapped, even because they don't even have the same access to positive emotions.
Okay, so I've never thought that much before about what the definition of an emotion is, but its etymology lines up with what you're saying about moving energy, because it is, it comes from the Latin to move. I just looked it up. So I think there's some truth there. But my general perspective on kind of what's more important and do they interact between cognitive and emotional work versus biochemical work, I think no one is, for some people, they are, let's say, on a 1 out of 10 biochemically, and there may be an 8 or 9 in terms of how they conceptualize how they should be handling their thoughts and emotions and life stresses. But their biochemistry is just so bad that the cognitive work they're trying to do doesn't pay off. And that person primarily has to engage at the biochemical level to make progress. And then there are other people who
I would argue.
Go ahead.
One second here. I don't want to separate them, because I would argue all people need to engage in both. Like I don't want to separate. I don't want to say that,
I agree with that, but I agree with that, but for some, it's possible to be much worse on one than the other. And, everyone has to make choices about where they're going to put their focus at any given time. And most people tend to get stuck in a rut where they put it in one place and then they forget to take it out. But, yes, that's true. But let me finish the thought, though. So there are other people who are, let's say, they're 7 out of 10 biochemically, or even a 5 out of 10 biochemically, and they're, a 3 out of 10 on how they conceptualize they should be handling their thoughts and emotions and so on. And I think that person's going to get more initial results out of cognitive work. I agree that everyone should be doing both. It's just that there are many people that are at the extremes where, they're trying to work on their stress handling through whatever means, talk therapy, meditation, gratitude journaling, or whatever it is. And it's just the biochemistry is making it such an uphill battle that they're not going to get anywhere until they address it. And most people are probably not.
But don't those things also impact? Don't those things you just described also impact biochemistry?
Yes.
Yeah, because consciousness does impact matter, and so I know I need a number of things in my life, or my mood is affected. If I'm not meditating, if I don't have adequate connection to nature and sun exposure, and if I'm not working out hard, everything becomes more difficult for me, as well as my nutrition, as well as my diet. So to me, that's indisputable, and any type of evolution in mental health care has to include all those things. But I also know the impact of the mind. The mind creates stories. The mind makes judgments. The mind goes in the past. The mind replays events that are painful. The mind goes into the future, and in that future can create scenarios that are catastrophic, all impacting our physical bodies and biochemistry in that exact moment that it's doing that. And this whole quantum physics, where consciousness actually has impact on matter, is just absolutely fascinating to me, because I begin to understand, or begin to think about what we do when we pharmaceutically try to intervene with nature. So tell me if I'm wrong here, that there's research that shows that living cells emit light, like actual photons that can be measured with photomultiplier tubes. Like scientists like Fritz Albert Popp discovered that healthy cells emit coherent light, while diseased or dying cells emit these chaotic light patterns. And the biophotonic emission appears to be how cells communicate with each other across the body, which is faster than a nervous system, faster than chemical signals. And this is where it gets really interesting to me, is that the primary source of this cellular light production appears to be the mitochondria. So I'm trying to merge the metaphysical, the spiritual, with the scientific, with the physical. So if from your research and how SSRIs destroy mitochondrial function, what happens then to this light production? Are we literally watching people's inner lights dim when they take these drugs? And can this explain why so many people on SSRIs report feeling dead inside? spiritually disconnected. In some ways, like people have completely altered their understanding of reality. They've become atheists. It's fascinating what I see these drugs do.
I think we need a lot more research on the light stuff. So it's if you look at the science that's coming out now about it, the overwhelming opinion is that photons are released through degradation of reactive oxygen species, and that, they call it ultra weak biophoton emission, that it's extremely small. I think that it's probably massively underestimated and super hard to measure because, on the one hand, a cell experiment is interesting. I've not done maybe the deep dive rabbit hole that you have or that some other people have. So I'm not sure what the definitions of coherent in those papers are. I imagine that might be kind of controversial in terms of how people define it, but it's very interesting. But I do think that, first of all, a cell is a cell, a human is a human. Humans do emit light, pretty much across the whole spectrum, but there's a lot more blue and green light, and very little ultraviolet light. And then, of course, we do emit infrared as well. But I do think a lot of the light that is made in the mitochondria is consumed in the mitochondria. So I think it's difficult to look at a study of like what are humans emitting and make inferences about what's happening in the mitochondria, because the mitochondrial complexes do absorb light. So like, for example, complex 4 in the mitochondrial respiratory chain can absorb light everywhere from green to near infrared. And so, if the light's being produced in the mitochondria and consumed in the mitochondria, I think it's incredibly hard or even if it's commuting from one cell to another, if it's to the extent it's doing that, the receiving cell is absorbing the photon. So we need way more research on like even how to model the proper experiments with that and understand what it's doing at a whole body level. So I think it's fascinating. I did look at it in the course of the SSRI series, and I can't say a whole lot about it. So I do think that it's one of the fascinating puzzles to solve that is unsolved is serotonin and melatonin both act on the outside of the mitochondria to bind to serotonin receptors in the case of serotonin and to melatonin receptors in the case of melatonin to prevent the normal response of hypoxia, which is to shut down the respiratory chain because you don't have enough oxygen to run it. Now, I looked at that and I said, why would they do that? And why isn't it bad? Because the reason you shut down the respiratory chain when you don't have enough oxygen and you turn on anaerobic glycolysis is because if you don't do that, the cell's going to die. So serotonin and melatonin must be doing something inside the mitochondria that substitutes for oxygen. And that is what the research shows. It shows that the mitochondria keep making ATP in the respiratory chain, even though they don't have oxygen. And I have two possible things that I suggest might be going on. One of them is that melatonin could get oxidized and then could act like oxygen to shortcut the respiratory chain at the point of cytochrome C, which would sacrifice about 20% of the oxygen, 20% of the ATP made, but it would allow it to cycle through in the absence of oxygen. And then the other idea I came up with is that melatonin is translating ultraviolet light being released toward the greener part of the spectrum, which appears to be absorbed by complex 4 and allow ATP production in the absence of oxygen. But I couldn't find good justification for that based on the spectrums of light being released from humans. And so I left it as an open question in that article because of what I just said, which is, it's one thing to study what light is being emitted from humans, is a totally different thing to understand what light is being produced and consumed at this, in close proximity in the mitochondria. So I think it's interesting, but I don't think we can say much conclusively about it.
Great. I'm not going to ask you to go down this rabbit hole with me. I believe there's intent. It's purposeful. I think we're under attack. The pesticides, our food sources, the biochemicals, the mRNA. To me, it's clear. It's obvious. There's a transhumanist movement that exists, or always has been. There's certainly trying to alter and change.
Don't forget the masks and not being allowed to go out of your house.
All those things, right? So maybe we're on the same page there. Maybe we're, that we're from the same camp. But I see this as an anti-human movement, and we need to protect ourselves from sociopaths. So that's why I want to get into two areas that are near and dear to my heart, because I work with these people and groups of people. One of them you already mentioned. It's post-SSRI sexual dysfunction, because as you said, people are reporting complete loss of sexual functioning that persists for years. I think this is an attack on life. It's sometimes permanent. It sometimes occurs after stopping the drugs, in withdrawal, as a withdrawal reaction. I want to ask just two questions to the best of your ability for a general lay audience. Can you explain what's happening that causes this? And then is there hope for these patients worldwide right now who this has like zapped them of their will to live? They are blunted, they are numbed, their genitals are numb, they can't experience orgasm. A lot of things that make life worth living, they're not able to experience. And this is becoming a very well-organized group of people who are trying to get funding for research and certainly looking for hope in this. Is there anything that you can share with us?
There's some. So there's not a whole lot on PSSD compared to there being a few trials of drugs for SSRI associated rather than post SSRI sexual dysfunction. I would say, first of all, the SSRI, at least several of the SSRIs and possibly all of them, inhibit nitric oxide production. And nitric oxide is not only is it the dilator of blood vessels and therefore necessary for erections, but it's also the parasympathetic sexual neurotransmitter and is therefore necessary for arousal in both sexes. And so pharma, I really don't think there's anyone who should be on Viagra. But Viagra is sort of targeting the downstream effects of nitric oxide with respect to dilating blood vessels, and is not so much as targeted toward the neurotransmitter effect on the arousal. And I think everyone who's on, this is a slight tangent, but it's very, very related. I think everyone who is on Viagra is suffering from a nitric oxide deficiency. And in some cases, it's just they don't eat enough protein, which supplies the arginine that you use to make the nitric oxide. And in other cases, it's oxidative stress and zinc deficiency and sulfur deficiency. So I think on SSRIs, though, you have a regulated inhibition of nitric oxide production by certain serotonin receptors. And so I do think like the best solution to that is to not be on the SSRI. But if it's persisting, if it happened on the SSRI and then it's persisting, it could be an epigenetic response that's just sealing in that same effect. And you're probably going to get the best results from like 2 to 10 grams of citrulline supplemented a day, divided across the day and taken before meals. But again, you should check your diet because a lot of people just aren't eating enough protein in the first place. And then nitric oxide production does depend on having all the antioxidant nutrients, having a bunch of B vitamins. There's so much to it. And then if you look at the trials, there is evidence for Viagra or Cialis helping. There is evidence for bupropion helping, and there is not really any trials on testosterone, but there's definitely a lot of people claiming that it helps PSSD. And some natural alternatives to that, bupropion, which is Wellbutrin, you could play around with gelatinized maca root, which has similar effects. The Viagra or Cialis, you could play around with nitric oxide boosting activities like the citrulline I was just talking about. There's an interesting case report, though, that had someone who had like zero sensation in his penis and just a few weeks of near infrared low powered laser on his scrotum and his lower spine got a 40% increase in penile sensitivity, which is, powerful validation of sunning your balls. It's just funny because that's an internet meme. But that's basically what they did, because the natural source of near infrared light is the sun. They put it on his balls, but there was a recent study that showed that infrared light to the chest while the eyes are blocked improves vision the next day. So there's definitely it doesn't have to be necessarily always applied to the exact location of the problem to have a benefit, but it makes sense to bias it toward that location. But that also, speaks very well for whether someone can do something at home, because it's one thing to go into a treatment for someone that has low powered laser delivered in a highly specific way. But there's a bunch of near infrared and red light devices that you can just buy one on Amazon and, target it for 5 or 10 minutes a day to whatever the part of your body is that's not working, and see if it helps, because that is a general mitochondrial booster. And I think that case report is a powerful demonstration that mitochondrial dysfunction was underlying the lack of penile sensitivity. And maybe he would have gotten 100% restoration with just that approach, but for longer or at a higher dose or something like that.
Okay. Another question I want to get to on attack on life is prenatal exposure to SSRIs. As you know, I was on the FDA panel hearing for SSRIs crazy. For pregnancy.
Yeah.
I think it's well-known effect on developing babies, especially in the first trimester. And there was a level of darkness to some of the presentations and to the media coverage afterwards, because what they basically want to say is there's this disease called depression, and that is what would account for any negative effects to the developing baby, and therefore you need to take an SSRI to prevent that disease from emerging. Tell us what you know about prenatal exposure, SSRI use for pregnant
I don't
women.
know a whole lot, but when I saw that, I had an immediate reaction, which is the greatest expression of the serotonin transporter is the placenta. And so, why is it there? Well, clearly to get serotonin across the placenta. And if you're on an SSRI, you're blocking it. So whatever the importance of serotonin is to the development of the baby, which is obviously very important if the placenta has the highest expression of the serotonin transporter in the body. And so you're interfering with the serotonin doing that. This just goes to show you how dumb the discourse is that everyone thinks that SSRIs boost serotonin or something like that. Like it's one thing for a random person on the street to say that, but the fact that doctors and research scientists think that SSRIs are serotonin boosting drugs is it speaks to how pathetic the state of science within medicine, psychiatry, and pharmacology is. Like, it's really bad.
Yeah, I think in reading your article, you were very clear about some things. I want to make sure I get it accurately. You mentioned that. Give me 1 second here. That SRIs actually deplete serotonin by 14-fold, while they claim to increase it. Like, how is this possible that the entire medical establishment has it backwards?
In the blood. I think it's, the problem is that the problem is that pharma hijacked SSRI science and fundamentally perverted it. So, I mean, that's the story. Serotonin science has become the marketing arm of SSRI sales. And so it's like, would you get your information about something primarily from the sales and marketing department of some company that's selling something? You would think no, like there's probably better information, but the research literature since 1986 on serotonin essentially is the sales and marketing department of the SSRI, the SSRI sales and marketing department of pharma. So I think that's part of it. The other is that doctors, present company excluded, but doctors are generally not, you're not selecting for the same types of people that you would for a research scientist who want to understand all the details of something. In general, doctors are split between people who are very good at relating to their patients and care about them a lot, and then people who are like really good at making protocols and managing society. And so you have, that first type mostly deals with the patients, and that other type controls them by making, going into the bureaucratic positions that control everything. And then most doctors also, they don't have that much time, especially if they're working in this standard model. And so the main thought process that they have is like, how do I get my patient to understand this and to comply with what I'm telling them? And that leads them to very much like simplifying things. And I've been a teacher, so I also like simplifying things, but I've always been more of a research scientist than I've been a teacher. And so the, wanting to understand all the details wins out. But it's, and most doctors have no idea what info they're getting from pharma either. There was a study that was done like 10 or 20 years ago, and it asked doctors a bunch of questions and then asked them where they heard it. And they identified like 80% of the stuff that they were saying could not be found in the scientific literature, and it could be found in the pharma marketing literature, but the doctors thought they were getting it from science papers. And everything has changed since the internet, but when I was first in grad school, my first assignment in a like intro to the program thing was to go get a journal out of the library and look at it and report what we found. And I was stunned to see that New England Journal of Medicine reminded me of Flex that I used to read when I would do my cardio when I was warming up in the gym, and where it was like Flex would have what looked like an article, but it was really like a 3-page ad for some kind of fat burning supplement. And, but it would look like an article. And so New England Journal of Medicine would have these 3-page pharma ads. And the only difference in that allowed you to tell was that the color of the logo was different at the top of the page. It otherwise looked exactly like the journal article. And it's just inside, so if you imagine a doctor who like was in their prime 30 years ago, there's an entire generation that just like doctors like 20 years ago, doctors didn't go on PubMed and search for things as much as they had a favorite journal in their office where they had, all the NEJM or like all the Lancet or whatever, and they actually physically read things. And so you have this, I think the internet is breaking it free right now, but you have this persistent, like the last 3 generations of doctors who are the ones who trained the ones who are in their prime now, grew up on this like total inability to tell the difference between pharma and science because pharma paid science to make it so you couldn't tell the difference, And so I do think it's getting better. And as it's getting better, the cohesion of the standard model is falling apart. We're watching it happen right now. And that is thanks to the internet. And that is thanks to the blowback against the COVID censorship and all that stuff. But I think it's just most doctors are just trying to help their patients, and they're just trying to communicate in ways that help their patients. And they're hearing most stuff come down from pharma, and they can't really tell the difference. And then, the people doing, like, researchers tend to stay in their own niche, and the ones working on pharma mostly work for pharma. And so you don't have a good system where there's uninterested parties that are trying to understand the truth of SSRIs. You have we're moving towards that now, but I think that's what's going on.
Final question here. Clearly, so my belief is that, there are psychological factors and environmental factors that certainly influence mood, behavior, emotional reactions. And I believe there are physical, biochemical ones as well. And I think they both can interact with each other. But let's say you're a psychiatrist, okay, and you are trying to advance your profession, and you want to target the chronic disease epidemic and its impact on mental health, mental well-being. Somebody comes to you and wants to start an SSRI as a frontline treatment because, they've been down in the dumps and they're a little bit anxious and they're in their head a lot. I want to know, what would be the advice you would provide them? Are there any situations where you would recommend an SSRI? If so, what would they be? And just generally speaking, how would you direct a person to be able to optimize their life, to get them active, to start overcoming whatever they're overcoming? What would be that frontline intervention or recommendations that you would really try to guide those patients with?
I would look at their diet and exercise first. I think most people aren't hitting the low-hanging fruit of good health that is relatively non-controversial and it's accessible to learn about what a good diet is and good exercise program, but a lot of people aren't even hitting that. I would look at what their symptoms are and try to draw some inferences about what the nutritional implications might be. So as an example, if someone is overstimulated, that's one thing. If someone is ruminating a lot, that's another thing. If someone is anhedonic, that's another thing. And although I think there are, and I think you would probably maybe think this more strongly than I do, but I do think there are profound limits to trying to modulate certain neurotransmitters and affect a psychological outcome. But there are things you can do nutritionally, and there are biases that are going to be created by certain nutritional limitations. So for example, like if your diet is super low in tryptophan, you are probably going to have lower serotonin, and there are psychological effects that you expect from that. But I think the roots to depression are multiple. So if you, I'll give you a few nutritional examples. So if you have low methylation, which is impacted by B vitamins, by certain amino acids in your diet, and by a few other factors, that is generally going to make your mind more sticky than it should be. And there are pathological outcomes to having. So we could describe mental stability and mental flexibility as a trait spectrum. And then there are pathologies on either side at the extremes. But if someone is ruminating too much, I would definitely look at their methylation as a first order of business for getting them more dialed in from the basic 101 of a good diet to what might be individually supporting their needs. And I guess another example would be if someone's anhedonic, I'm going to be thinking about dopamine being low before I'm going to be thinking about methylation or something like that. So I do think it helps to have I did I think a 5-hour monologue podcast called Nutrition and Neuroscience a few years ago. And so people can still find that on YouTube or Spotify, I think, where I go into detail about this. But I think there are things, I think within a limited scope, you can look for things where maybe certain nutritional deficiencies are causing global losses of certain neurotransmitters. And then I'm not an expert in cognitive behavioral therapy or any other such technique, but I do, I agree with you that that's never something that should be given less of an emphasis. And then I think, a lot of tough cases are, I think it's much more common than people think it is to have rare mutations that impact metabolism negatively. But it's also very labor intensive and expertise heavy to kind of unravel what those are. But I do think when that becomes more easy and more accessible, I think that will help a lot in individualizing people's diets. That's where I'd start.
What about the role of sun exposure, connection to nature? Thoughts on that?
Oh, well, I would consider that kind of the basic 101. So I guess I didn't say anything about what the basic 101 is, but so I do think that everyone should be seeking at least 30 minutes of unprotected morning sunshine outside. There's not much of an excuse. Like, even if it's raining, it would be better to go out under an overhang and still get outside, because people think that when it's dark out, it's like too dark to get morning sunshine, but that's not true. The outdoors, like, your eyes adjust to the light and make on purpose. Your brain does that, which makes you grossly underestimate the difference between the outdoors and the indoors. You can tell by the way your pupils react. Like, if it doesn't seem, if you go outside on a cloudy day and then you look at your pupils, they're going to be smaller than they are when you come inside. And you're just not going to notice that it's like 100 or 1,000 times brighter outside. So I think 30 minutes of outdoor sunshine in the morning. I think everyone should get a small amount of unprotected sunshine near solar noon, sufficient to keep their vitamin D levels optimized. But you definitely want to, you do not need your skin to change color in order to maximize your vitamin D synthesis. And from a skin aging and cancer risk perspective, I think you want to regulate that so that the amount of midday unprotected sun that you are getting is at least not sufficient to burn you, and ideally not sufficient to turn your skin pink, even temporarily. And so I think the whole day should be spent as outside as possible. And when you have to be inside, you should design as much as you're able to your inside environment to have as much natural light as possible. So you should go through most of the day without the need to have artificial lights on. And if you can't, then that should be aspirational for your next house or work environment. And for sure, if you're depressed and you're working in an office that is not providing most of its light by natural light and has gray walls, then you should immediately request to be moved to a part of the building that has warm colors and a window. I worked one time. I didn't know why I was so depressed. And it's because I was working in a building that was built in like 1960 or something like that. And the walls were painted gray and it was real dark. And then I moved to another building on the same campus, and the walls were either white or they were like light red. And there were windows everywhere, including in my office. I wasn't depressed anymore. So that's definitely a thing. But I think you want to be if you're out a lot in the middle of the day, you should be protecting yourself with clothing. Wearing a wide brimmed hat outside at noon is better than putting sunscreen on, and it's better than going out with no protection on your face for more than it takes to maximize your vitamin D synthesis, because you are going to wind up being more wrinkled than you would want if you're out at solar noon. And I don't think it's ancestral either. If you look in Africa, like anywhere where it depends where you are, of course. Like if you're in New York, you can probably spend all afternoon outside most of the year, even if you have really light skin. But if you look at like the tropics, even the animals and the humans take shade in midday from the sun. They're not out in the sun all day. Like they're taking a nap under a rock or something like that. So I do think there's a corner of the alternative health space that thinks that like you just want to be completely in the sun all day long, and even if you get pink and shriveled up, it's good for you. And I think that's ridiculous. But you want as much indirect sunlight as possible. So like the ancestral thing is to take shade outside. It's not to be indoors and require an artificial light. So and this is a societal effort. A lot of people don't, like I'm lucky enough to have the choice of where I'm working. A lot of people don't have that. And so I do think that we need a societal effort to, I think this will be huge in battling depression. We need a societal effort to make the built environment of people's workspaces and education spaces as filled with indirect natural light as possible.
One final question. Is there any situation at all that you would recommend an SSRI?
Well, that's not really my job. So I on the one hand, my position is I wouldn't touch it with a 14,000 foot pole. But and my response to people who say that their life was changed in a positive way with an SSRI is that, like I could have helped you figure out how to get even better without it. But at the same time, I know that it's going to take a massive amount of educational work to reach the people that don't have access to good information. So I'm not necessarily going to fault the person who really doesn't know what I know for giving some people who are really suffering and appear to benefit from an SSRI. But I would never advise anyone that I know in any capacity to go on an SSRI, because I think if I have contact with that person, I could definitely help them have better alternatives. But I do think if you do have, there's this guy on Twitter, on X, that follows me, and he's been reading my whole series, and he puts everyone on an SSRI. think his name's Patchy Pete, something like that. And I don't know if I've changed his mind about any of it. But it's interesting that he said that he never uses them for longer than a year. So he puts hundreds of people on an SSRI but it's always temporary. And what's interesting is, if you look at as I was saying before at the beginning, if you look at the median length of time someone's on an SSRI when they wind up in these internet forums that there have been peer-reviewed studies on, where they've contacted all the people in the internet forums and collated the data and stuff. It's 8 years. And I do think 1 year is too long, but I think there's a huge difference between 8 years and 1 year. And I think it's a complete catastrophe that the people prescribing these meds have no idea that that's true. And I don't think he thinks that's true. Maybe he does now. But when he first said that, he was saying that because he didn't think they were needed. Like, he thought he was correcting the serotonergic system using a 1 year biohack, basically. So I do think that if you wind up on an SSRI, you have to be super conscious about trying to spend as little time on it as possible. And I think 1 week is better than a year, but anyway, go ahead.
Yeah. What I wanted to respond to Patchy Pete, and I don't know if he's a real psychiatrist or not, but I'll
I don't know either, but that's
overwhelmingly. Yeah. Overwhelmingly, emotional struggles are episodic and traditionally have been episodic. So before this pharmaceutical revolution, going through a rough patch in a person's life would naturally remit. It would resolve itself without any professional intervention. And which is why I'm in support of watchful waiting. So I often get questions from primary care doctors, for example, well, what do we do? We're forced to intervene. Well, an intervention is also all the things that you just described, that could actually be done and could be provided in a 10-minute meeting with your primary care doctor. But watchful waiting, you'll see how these conditions naturally resolve themselves. So what Patchy Pete actually sees often is people are in distress when they first see him, and he just sees the normal human adaptation process of resilience and problem solving. People face their problems and overcome them. What we're doing in modern psychiatry is we're taking episodic conditions and we're turning them into chronic ones because of the drug effects. And then you get the people off the drugs too fast and you misrepresent withdrawal symptoms for relapse, and boom, this is why psychiatry creates mental illness. So those were my thoughts to Patchy Pete.
There was a randomized controlled trial where I didn't read the whole paper, but I think the design was they randomized psychiatrists to advise themselves or someone else what to do in the same situation. And it was like 80% of them would advise themselves watchful waiting, but would advise SSRIs for their clients, their patients.
I read that. I saw that. I thought that was fascinating.
Speaks very poorly of the psychiatric profession because the wording was if the patient came to you and asked you, what would you do if you were me? Which means that most psychiatrists are liars. Because they told the patient that if they were them, this is what I would do for myself. But when their task was to prescribe it for themselves, they did the opposite. That's just lying to your patients, So I think that you can understand their mindset, which is, well, I have the expertise to watchful wait myself, but it's too dangerous for someone without the you can get a handle on what they're thinking, but if you're telling your patient that I would do this for myself if this were me, when you wouldn't, you are a liar, and that is a problem.
This was a great conversation, Chris. I really do. Yeah, so true. I really appreciate you coming on. Where can people discover your work?
Chris Masterjohn, PhD.substack.com is where I publish my newsletter, which is where I'm most active. And if you go to mito.me, you'll see my brand new mitochondrial test, which can help bring you to the next level if you're still stuck after you've done all the basics.
Great, Chris. Listen, this was an absolute radically genuine conversation. I'm grateful for your work, and your 10-part series on SSRIs is illuminating. I do encourage everyone to take a look.
Thank you so much.
Chris.
Thank you for having me on.